All right, so here's your first example. I want to take the first derivative of x squared plus y squared equals 36. Now again, I'm hoping you look at that and you realize, oh, circle, center's at 0, 0, radius is 6. So we want to take the first derivative, and remember, first derivative is the slope. It's the slope equation for the line tangent to the curve at a given x value. But we're not doing those yet. We're only doing first derivative for now. We can move on to finding the equation of the line tangent to this circle at a given x value next week. So for now, let's just focus on doing the first derivative. So we have 1, 2, 3 terms. We have to take the derivative with respect to x. So our first term involves x. So you're only going to apply the power rule here. So the derivative of x squared is going to be 2x to the first. Remember, you subtract 1 from the exponent. And we're taking the derivative of x with respect to x, so we're going to write dx dx. All right, bring down your plus sign. Now we're going to take the derivative of y squared using the power rule. So we get 2y to the first. But now we're taking the derivative of y with respect to x, so we're going to write dy dx. And then now we're taking the derivative of a constant, 36. There's no x, there's no y. And you guys know that the first derivative of any constant is 0. So we're just going to write 0. All right, so we just did the first step. In the first video, I gave you your 2 steps. Take the first derivative, then get dy dx by itself on one side. So one of the first things I suggest, dx dx, those cancel each other out. So you don't even need that. You can just get rid of that. So let's just clean it up. It becomes 2x plus 2y dy dx equals 0. So now our goal is to get dy dx all by itself on one side. So I'm going to start by subtracting 2x from both sides. So you get 2y equals, or I'm sorry, no you don't, 2y dy dx, sorry about that, equals negative 2x because we had to subtract the 2x from both sides. Now since we want to get dy dx by itself, we have to divide both sides by 2y. And these cancel, so we get dy dx equals, and the 2's cancel, negative x over y. So there's your derivative using implicit differentiation. We're not going farther yet. For now, this week, all you're going to do is practice getting the first derivative.